The lateral area, don't say this out loud, let everybody have a quick second to think about this. Lateral area is what part? Everybody got their answer? What part?
Guts.
The guts, right? The middle part.
Bases.
Don't include the bases. So the first thing you got to figure out is what kind of prism it is. And if it's not a rectangle, then that will be your bases. And so you're going to take, usually the lateral area is always what shape? A rectangle. It will always be rectangles, but sometimes it's a rectangular prism, so then you have to do your rectangle. I was doing some of these problems today for a little thing that we're going to do down the line for you guys. So I was looking at this. Realistically, if you have a rectangular prism, there should be 3 different numbers on the problem. You're going to multiply all the numbers in every combination that you can and then take it times 2. Because it would be the top and the bottom, the left and the right, and the 2 ends. That's another way of thinking of a rectangular prism. Okay? And then we did the surface area, which just included the what? The bases, right? But we included the bases with the lateral area, but it's essentially everything. So we compared it to wrapping paper. Today we're going to talk about a cylinder. Because realistically, a cylinder is essentially a prism, but why is it easier?
Because it's 2 circles.
Because it's always the same thing. The formula for lateral area and surface area is exactly the same thing for every single cylinder. That's why it's nice. Okay, but before we get to this, so a cylinder is simply a prism, and I'm going to put it this way, right, in quotation marks, because technically it can't be a prism because why? Because it's got a curved side, right? But a prism with bases as circles, right? That's what makes it our easier, I guess. Now, before we do this, though, we need to introduce 2 more things. We need to introduce an axis first.
Is this still 12 2? Yes. It's 12 2.
The axis of a cylinder, okay, is kind of like the axis of your car. So what's an axis? It connects the what?
Wheels.
The wheels, right? So if the wheels, oh yeah, an axle. This is an axis, but
Same thing.
yeah, you kind of get it, right? Most people didn't even notice it until you brought it up. See? So if it's an axis, it acts as the axle. So just like an axle, it's connecting the tires, which are essentially circles. The axis is going to do the same thing in a cylinder. So the axis is going to be a segment between the bases that connect. What do you think it connects? And
Everything.
what would it connect in an axis or an axle?
Centers.
The what?
Centers.
The center of those circles, right? So it connects the centers of your circles. Anybody else?
Yeah.
Big
Just
shot.
point the fan away from Geom.
Actually,
Okay, so what does this remind us of from yesterday, though? Essentially, this is what we kind of talked about as being the what in a prism. The height, in a sense, right? So this is, though, exactly when it's in the center to the center. So here's the difference. If it's a right prism, what did we mean by a right whatever yesterday?
Right angle.
It formed a right angle, but on the ends it was also a what?
regular volume.
Regular polygon, right? So they're perfect in a sense. Okay, if it's a right cylinder, here's my cylinder. Okay? axis is going to connect the two centers and form a 90-degree angle. Okay, so in a right cylinder, this is my axis, but it's also the what? The height. And then yesterday we also introduced what besides a right prism. What was that other word? An oblique prism. And what was true about an oblique prism? They're still parallel, but they're on the slant. So Riley said we have to draw it at two dimensionals, right? So we end up doing this. Right? So this is my oblique cylinder. My two circles are just still parallel to each other. We still have an axis, which is in the middle. Okay, so this is still my axis, but now my height has to be where? My height has to make a right triangle. So my height is going to be out here where we can draw that dashed line. So you might see a couple of these in the homework today. Okay? Don't get confused when they talk about the axis. In a right cylinder, they're the exact same thing, which the majority of ours are. So we need to get back to the formulas, right? We're talking about lateral area again versus surface area. So the lateral area is still my guts, right? Yesterday, what was the formula for the lateral area? Capital P times H, right? Or we came up with capital P times D yesterday. D could replace that H because it's really the distance between the bases. And some of you didn't like it when it was on its side, so we called it D. That's okay. Well, this is where it gets easier because if we're talking about the perimeter in a circle is always what? 2 pi r or pi d, right? So whichever one you like better. And then we're going to multiply it by the h. That's the lateral area every single time for any cylinder. Because it has to be a circle, right? And the perimeter of a circle is the circumference, which is either one of those. And then we're still going to do the distance between the two circles. So it's the exact same formula from yesterday, but we can simplify it right off the bat. And then with our surface area, we're still going to use the same thing. So whichever one you like again, 2 pi r h or pi d. Because remember, what was surface area? It was the lateral area plus what? 2 capital B, right? And why was it 2? Because there's two bases, one on the top and one on the bottom. And why is it capital B? It's the area of the base. But now we can simplify that because we know what the base is every single time in a cylinder, right? So what's the area of a circle? R squared. So we're going to say plus 2 pi r squared. And then obviously you could do the same thing down here if you like pi d better than 2 pi r.
So what is that? What the LA plus 2B equal?
This is what we did yesterday. The lateral area, which is over here, which is really perimeter times height, plus 2b, which is the area of the base.
So what does that find?
This is my surface area. So remember, it's always the area of the base and the perimeter of the base. That's more for yesterday's because of our shapes, right? Because yesterday our bases could change shape. Oh yeah, we need H. Good call. Thanks. Pi times diameter times H. The height. So this is still surface area, whichever one you want. And these are all lateral area over here. So essentially it's still pH and it's still LA plus 2B. But we're simplifying it because we know what it is every single time. Does that make sense? So again, when you have to write this formula down, I want you to be as specific as you possibly can. So you either need to write this or this instead of LA plus 2B. You have to describe what all those pieces are. So my lateral area will always be 2 pi RH. I don't know, I always go to this one.
How do you find the area of the base?
How do I find the area of the base? Pi r squared, because it's a circle. Okay? That's why we were kind of happy you weren't here yesterday, because it was kind of confusing something.
It was, I'm more confused now.
Gabe, you just broke your lead and it landed on my desk.
Nice.
Nice. Nice.
It flew in the air onto my desk.
Alright, here we go. Whoa. Where's the shape? Find the lateral area and the surface area of the cylinder. Round to the nearest tenth. There's a shape. Everybody agree it's a cylinder?
Yeah.
Right? It's a prism. It's got a circle on the top and one on the bottom, so we call it a cylinder instead of a prism. Okay, so. Say it one more time.
It still just say it's perfect.
No, because a circle is a circle. Right? A circle realistically is a perfect shape.
It can be an egg.
Like that's always gonna be a central.
Yes.
Not
Yes.
good.
The only time that this isn't going to be perfect is if it's on a slant, like this oblique one.
In that case, you have to do from the height.
Then you probably have to use Pythagorean theorem or something. Okay? So,
We found the perimeter of the base.
let's go to work. 2, which one do you want to use? The top one or the bottom one?
Top.
Top one. So, do we got all the information? 2, pi, what's my R? What's my H?
18.
All of that, when they're written next to each other, just means I do what to it? Multiply them all together. So write that number down. Then I gotta come over here. Remember, this is a little bit more of the order of operations, right? So R squared, in this case, would be what?
14.
So what's 14 squared?
196.
700.
196.
196 times 2 times pi.
I wouldn't be,
I can go in any order I want, right? The most important thing, though, is that I square my radius first. Well, technically, you can take 2 times pi if you want.
I'd probably do that first.
Okay. And then, at the very end, you add those two things together. So, what'd you get for just the lateral area part? Lateral area, shouldn't have been that big. Should have been.
How do you find the
Right here, buddy. That
So what's
formula
the
right there.
pH then?
The pH is the same thing as this. Those two are the exact same thing.
That's the starter one.
The perimeter of my base is 2 pi r. The h is the height between the two bases. That's what we did yesterday. So, what'd you get? 1,583.4?
yep, exactly.
Now, again, remember, if you use the pi button, do not round until the very, very end. So, if you use the pi button, this is probably a little different number. No? Still the same? Okay.
Next one might be.
Here we go. So now we do this formula, 2 pi rh. So we just did this, right? So you're going to use that number, but now we have to do 2 pi r squared. So when you did your math, you should have got a grand total of 2,814.9 what? What was it?
Inches.
Was it?
I don't know.
There's feet.
Or you're just throwing out some here. Feet squared. Why is it squared? Because we're still just finding an area, right? So even though that we did a lot of things, it's still just an area. So it's feet squared. Okay? Now again, I usually don't count it off when you're going so fast that you put centimeters in for every single answer.
Shoot.
Some people have done that, right? So you realistically slow down and look at the shape. You know what I'm saying?
Yep.
So a couple things that could happen would be what? Well, again, they could give us, now this is again pretty much the same thing, but what could happen different? One, they could give us a diameter. So then you have a decision to make. Do you go back to, or do you just use this one, or do you go back to this one? It doesn't really matter, you're going to get the same answer, but if you go back to this one and they give you a diameter, the first thing I got to do is divide by 2. Okay? And then with these oblique ones, you might have to find one of those other numbers. Meaning, if they give you the length of this, and they gave you the axis, you might have to find that height by doing Pythagorean theorem. Or you might have to use some kind of trigonometry. Now those are getting a little bit more complicated, but, and I think you'll see more of the oblique things when we get to volume than when we do lateral and surface. Okay? But essentially it's the exact same formula, we're just manipulating it today a little bit. Okay? Do we need to go through this one? Okay, does anybody have any other questions?
That's the whole lesson.
That's the whole lesson.
Well, you missed half.
Is the answer
You
yes?
missed half.
You missed two of, you missed two of the.
This one you think is A?
Yeah. It's A.
He cheated, I watched.
No, it's not. He definitely has all the work right here.
Attaboy. Alright, so the rest of the time you gotta work on some problems. We will have a bell ringer tomorrow over this, right? Hold on one second.
That's all we got today for 12-2 surface area.
You're gonna have to
Here's
make that
on
up,
cylinders.
Mr. K.
Say it one more time, bud.
Or